Okay, so the first thing we want to do is, it's asking us to graph this. So the first thing you want to do is state the domain of the function. And the domain is basically so that it can help us just kind of see where the function is going to be graphed, okay? Okay, so I'm going to put the domain here. Since we have a fraction, then that means that there's going to be a restriction. So we set the denominator equal to 0. Okay. So what this means is that your domain is all real numbers except for 0. Okay. So in your assignment on WebAssign, you get to choose which option is the answer. So I think they have it in Word. So all real numbers except for 0. Or you can write it in interval notation. It would be from negative infinity to 0, union 0 to infinity. Okay. Then it says to identify all the intercepts. So we'll start with the x-intercept. I'm going to write it on this side to save space. Okay. So to find the x-intercept, you set y equal to 0 and then solve for x. Okay. So I'm going to have 0 is equal to x squared minus 4 divided by x, multiplied by x on both sides. So we get x squared minus 4 equal to 0. Add the 4 on both sides. Take the square root. So x is plus or minus 2. Okay, so the points that we have here are negative 2, 0 and positive 2, 0. For the y-intercept, you let x equal to 0. So anywhere you see an x, you plug in a 0. But what happens here is we have 0 in the denominator. Can we have a 0 in the denominator? No, right? So this means that there's no y-intercept, because we can't divide by 0. I'm going to write here D and E. Does not exist. Okay? The next thing is to find the vertical asymptotes, horizontal or slant asymptote. Okay? So we'll start with the vertical. So for the vertical asymptote, the first step is to factor your numerator and denominator. So x squared minus 4 can be factored as x minus 2, x plus 2. And the reason you want to factor it is so that if there's common terms, then you can cancel them out. Okay, and that creates a hole in the. Here we cannot cancel anything. So to find the vertical asymptote, we set the denominator equal to 0 and solve for x. So here it's already solved for x, right? So this is my vertical asymptote. Horizontal asymptote. There's 3 rules, okay? So let me just repeat those. So m is less than 0, then n, m is equal to n, m is greater than n. Okay. M and n are the degrees. Okay. So let me write over here, m is the degree of the numerator, and n is the degree of denominator. Okay. So the first case, if m is less than n, if the degree of the numerator is less than the degree of the denominator, then we say that y equals 0 is your horizontal asymptote. Okay. If the degrees are the same, then your horizontal asymptote is going to be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So ln just stands for leading coefficient of the numerator and leading coefficient of the denominator. And then the last one is if m is greater than n, there's no horizontal asymptote. Okay. However, so maybe I'll put it here. However, if m is greater than n by 1, if m is greater than n by 1, then there exists a slant asymptote. Okay. So if m is greater than 1, if m is greater than n by just 1 degree, then there's a slant asymptote. So those are the 3 rules to help you identify if there's any horizontal asymptote. Okay? And we'll have some practice here. So in our example, the degree of the numerator is 2, and the degree of the denominator is 1. So the top one is bigger than the bottom, so that's going to put you in case number 3. Okay? So that tells you that there's no horizontal asymptote. Why? Because the top one is bigger than the bottom, the degrees. Okay? However, if there's no horizontal asymptote, then you need to ask yourself, is there a slant asymptote? Okay? And the way we figure out if there's a slant asymptote is to ask ourselves, is the degree of my numerator greater than the degree of the denominator by just 1, right? So since this is 2, this is 1, then it's greater by just 1. So there exists a slant asymptote. If this had been a 3, and this is a 1, then there's no slant asymptote, okay? So how are we going to find the slant asymptote? Synthetic division, or we can divide using long division. Okay, either way will work. Okay, so here, remember, in order to use synthetic division, you need to have x minus c. But since we don't have a minus c here, or a minus a number, then what could we use? You could use 0, right, to do the synthetic division. Or again, you can use the long division, whichever one you feel more comfortable with. Okay, so I'm going to use 0. Let me just write it here. And I'm dividing by x, but I'm going to put minus 0 just to help us see what the c is. Okay, so 0 is going to be your number that goes here. And then we have an x squared, so that's a 1. Do we have an x? We don't have an x in the numerator, so I have to use 0. Okay. And then I have minus 4. So I'm going to bring the 1 down. 1 times 0 is 0. 0 plus 0 is 0. 0 times 0 is 0. And then we get negative 4. Okay. So your slant asymptote is your quotient, whatever your quotient is. Okay. So my quotient here, since we started with x squared, then when we do the quotient here, we go 1 degree less, so that's going to be x. So y equals x is going to be your slant asymptote. Any questions on that one? So again, even though I don't see anything with my x, then we can assume that we have the 0. So then I use the 0 to do the synthetic division. But if you have a number like plus 1, then you would use minus 1. If you had a minus 1, then you would use a positive 1, and so on. Okay? So now that we have all this information, then we can sketch the graph. And the last step is going to be to find additional points. Okay? but I always encourage people to find the additional points until you graph everything you already have, because then you can choose which points you need. Okay, so let's go ahead and plot the ones that we need. Including our asymptotes if we have them. Okay, so I'm gonna plot my asymptote first, which is y equals x. So y equals x is just a line, right? And hopefully you know where this line is. This is the line that goes like this. Remember, since it's an asymptote, then I use a dotted line. Then we're gonna plot our x-intercepts. So I have an x-intercept at -2, so right here, and I have one at +2, so right here. Okay. And then that's all that I have, right? My vertical asymptote is x equals 0, so we need to plot additional points. So I'm going to write them over here to this side. So I always encourage people to get some on the left side and some on the right side of the asymptotes. And then you can pick as many as you feel is needed. Okay, some of us might need 1 point, some of us might need 5 points, and it's okay, whatever you need to graph it. So for me, I'm gonna plug in f of 1, this number. I wanna see what happens there. And then maybe I wanna see what happens to f of 3. And then the same on this side, I'm gonna do f of -1 and f of -3. So if I plug in a 1, I get 1 squared minus 4 divided by 1. And that gives me a -3. And then the next one would give me 3 squared minus 4 divided by 3. So that's 9 minus 4 is 5/3. F of -1. -1 is squared is +1, so that's a -3 divided by -1 is +3. And f of -3, -3 squared is 9 minus 4 is 5 divided by -3. So the points that we're going to graph are 1, -3, 3 and 5/3, -1 and +3, and -3 and -5/3. Okay, so plot those on your graph. So 1 gives me a -3. 3 gives me a 5/3, which is more than what? More than 1, but less than 2. So in between 1 and 2, so like somewhere here. And then -1 and +3. And then, what's the other one? -3 and 5/3. 5/3 would be like somewhere right here. Okay. So your vertical asymptote is going to play a key point here, okay? So your vertical asymptote was x equals 0. X equals 0. So when x equals 0, I'm going to use my pen so we can know where that asymptote is. It's on this y-axis here. Okay. You don't have to graph it when you're doing the computer. Actually, they give you graphs and then you can choose which graph it is. But I'm going to put it here just so that we can see it. So what do we know? You can plot more points if you like, but we know that the graph cannot get to the vertical asymptote here. So I know that my graph here is going to get closer and closer and closer to this line, but it's not going to touch it. Okay. And then I also know that it cannot get to the slant asymptote, so the graph is going to go down and it's going to get closer and closer to this line, but it's not going to touch it. Okay? And then the same on this side. The graph is going to get closer and closer and closer to this line, go down, but you cannot cross the vertical asymptote. Okay? So then you would look at your choices and get your correct answer. So it's a multiple choice question. So one, you could either graph it first on your own and then see which one looks like your picture, or you can look at each graph and then determine if it has the correct points. So we can look at the domain. Since I have a fraction, then I set the denominator equal to 0 and solve for x. So your domain is all numbers except for -3. So that would be from -infinity to -3, union -3 to infinity. Identify the intercept, so I'll do the x-intercept first. So the x-intercept, you let y equal 0 and solve for x. So my y is 0, and then I solve for x. Okay. So in order to solve for x, we need to multiply by x plus 3 on both sides. So x plus 3 and x plus 3 will cancel, giving me 3x plus 2, and 0 times x plus 3 is 0. Subtract the 2, divide by 3. So x is equal to -2/3. Okay, so the point here that we're going to graph is -2/3 and 0. Then we can find the y-intercept. So the y-intercept, you let x equal 0. So we have c of 0 is equal to 3 times 0 plus 2 divided by 0 plus 3. 3 times 0 is 0 plus 2 is 2. 0 plus 3 is 3. So the point here is 0 and 2/3. Okay, vertical asymptote. So we need to ask if we need to factor. The numerator, it's already factored. There's nothing I can do there. The denominator is already factored, so there's nothing I can do there. So I'm going to set the denominator equal to 0. So -3 is your vertical asymptote. Horizontal asymptote, the degree of the numerator is 1. The degree of the denominator is 1. So they both have the same degree. So that's going to be option number 2. Okay. So let me scroll down a little bit. So that's going to put you at this situation. So if they're the same, then you take the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay. So my leading coefficient here for the numerator is 3. So I'm going to divide 3. My leading coefficient of the denominator is 1. So y equals 3 is my horizontal asymptote. If you have a horizontal asymptote, then you don't have a slant asymptote. You can only have either or. So now we're ready to graph. So I'm gonna asymptote first. And alright, so x is -3, that's fine. And y is equal to 3, so that's up here. Now let's plot our x-intercept is negative 2/3. So that's going to be less than 1, right? So we can approximate it. So less than 1. So maybe like somewhere here. And what else do we know? The y-intercept is 0 and 2/3. So that's going to be like somewhere right here. So it's just an approximation. And then that's all they give us. Okay, so now you need to think about what do the asymptotes mean, right? Your graph is going to get close to them, but it's not going to touch it. And then, but if you're not sure, then that's where the additional points come in. So what I mean by thinking about the asymptotes, I know that my graph should get closer to this line and closer to this line. So maybe that's my graph, right? Maybe. But that's, if you're not sure, then you would plot more points. But we also have to know like what's going on this side of the vertical asymptote. Okay. So maybe the complement here would go like this. But we need to plot extra points just to make sure. Okay. So your additional points, so some good points to plot here is maybe x equals 1. You can do more like 2 and 3, or you can do f of negative 1, but it's probably going to be like really close here. We can do it anyways. But then you need something on this side of the graph, so maybe f of negative 4. Okay. So let's plug in the numbers. So we have 3 times 1 plus 2 divided by 1 plus 3. So 3 plus 1 is 3, plus 2 is 5, 1 plus 3 is 4. And then the negative, we get 3 times negative 1 plus 2, and negative 1 plus 3. Negative 3 plus 2 is negative 1. And then negative 4 would be 3 times negative 4 plus 2 divided by negative 4 plus 3. That's negative 12 plus 2, negative 10, divided by negative 4 plus 3, negative 1, so we get a positive 10. So the additional points that we got here is 1 and 5/4, negative 1 and negative a half, and negative 4 and 10. So 1 and 5/4 is a little bit over 1, right? So maybe like somewhere right here. And then negative 1 and a half is going to be like somewhere here. And then negative 4 gives me a 10. So negative 4 is going to be somewhere up here. Okay. So I can say that this graph is going to go something like this. Okay. And then if you need more points, because with my additional points, I only got 1 up here. But we know the behavior of these rational functions, so you can plot more points, or you can sketch your graph. And then you will look at your answers that they give you and see which one is going to look more like yours. Okay. I mean, you can get rid of some just by looking at the vertical and horizontal asymptotes. If they're graphed on the wrong axis or the wrong side, you eliminate that choice, and then you go to the ones that have the correct asymptotes. Okay. Questions on that? Okay, go to the next one. So this is just to find the vertical and horizontal asymptotes. So we kind of went over these rules already, but we can do the vertical one first. It's important that you don't forget to factor if you can, okay? Because that will change your answer if you don't factor. So 4x squared is already factored, and x plus 3 is already factored. So they're okay. So to find it, the vertical asymptote said x equal to 0. So we get my vertical asymptote is x equals negative 3. And then the horizontal asymptote, you want to look at the degrees. The degree of the numerator is 2 and the degree of the denominator is 1. Since the top one is bigger, then we say that there's no horizontal asymptote. Okay. It does have a slant one, but since it's not asking to find it, then you don't have to find it. So on your computer, you would just enter your answer as x equals negative 3. Okay. If it specifically says find the slant asymptote, then you would find the slant asymptote. Okay. If it exists. So any questions on number 3? Write the complex number in standard form. So the standard form of a complex number is a plus bi. Okay. So standard form means a plus bi. So when you finish your work there, your answer should look like a plus bi. The first thing you want to notice here is you have negatives in the parentheses. So we can get rid of those by using imaginary numbers. Okay. So I'm going to work it out kind of like the long way, but the once you get used to it, like if I see a negative here, I know that comes out as an I. Okay. But I'm going to write down why it comes out as an I. So I'm writing like an extra step. So the first thing I would look at here is that this negative, I can write it as negative 1 times 8. That would still give me a negative 8, right? And the same with the 32. Well, the reason I want to do this is because negative 1 I know is equal to I squared. By definition. Okay. Well, the square root of something squared is going to come out as itself, right? So again, I'm just taking, I can actually separate it as this. Normally, I wouldn't write all these steps, but in other words, what I'm trying to say is you don't have to write all these steps if you already know that it comes out as a 9. Okay. So I squared and the square root become a 1, so that's just going to give you I. That's just going to give you I. So from seeing this, you could automatically write it like this. So that's why I say if you have a negative here, you can get rid of this negative by putting an I on the outside. And the reason is all these steps in between. Okay. But in order to add two radicals, the number inside, which we call the radicand, has to be the same. So 8 and 32 are not the same. And we want to simplify them. So you want to think of two numbers that you can rewrite 8 such that one of those numbers is a perfect number. Okay? In other words, these are your perfect numbers. These are your perfect numbers on the 1, the 4, and basically it just goes on forever, and so on. Okay. So when I see an 8, I know I can rewrite it as 4 times something, right? So I'm going to rewrite that 8 as 4 times 2. So notice that I have 4 times 2. 4 is perfect, and it's going to come out as what when you take the square root? A 2, okay? The 2 cannot come out, right? So I know this is going to be left with the 2. Since this is going to be left with the 2, then the 32, you want to think of, can I use 2? Can 2 divide 32? 32 divided by 2 is what? 16? Okay. So this side, I can write it as 16 times 2. I could also write it as 8 times 4, right? But then that kind of leaves me in the same situation, right? So if I know that 2 is going to stay here, then I'm going to try to use 2 over here because I want them to be the same. Okay? So let me just rewrite it up here. That way we have room. So the square root of 4 comes out as what? A 2. And this 2 is going to stay inside. And the square root of 16 comes out as a 4. And the 2 is going to stay inside. So now we have 4i plus a 2i. Now they're the same. So I can add these numbers in front. So 4i plus 2i is 6i. Now this is really not in standard form, although the computer would count it correct if you just put it like this. There's no a, so you could have written it like this. But since that's a 0, I think that's why it doesn't matter if you just put this or this. Okay, question on that one. Okay, I guess I can go with 12 since we're here. So to subtract, I'm going to distribute the negative in here, so I get negative 6 minus 16i. And then I'm going to gather my like terms. So 2 minus 6 is negative 4. 3i minus 16i is negative 13i. We've used synthetic division. So you want to put your coefficients, 7, 16, 2, and negative 4. If you're missing any of the numbers up here, like if it's x cubed and you don't have x squared, then you want to use a 0. In this case, we have all of them. And what is my number going to be out here? It's a negative 2, the opposite of what you have down here, plus 2, negative 2. Bring down the 7. 7 times negative 2 is negative 14. 16 plus negative 14 is 2. Times negative 2 is a negative, is a 0. Sorry, negative 4. Negative 2 times 2 is negative 4. Plus 2 is going to be a negative 2. Negative 2 times negative 2 is a positive 4. So we get 0. Okay. So in some of the other columns where they're asking you to find the zeros, this would be your first step. Okay. And then your final answer would be to get the quotient here. So what is your quotient here anyways? 7. Since we started with x cubed, we're going to go with x squared plus 2x minus 2. So this is your quotient. So that's what you would enter as your answer. Okay. But if the question said find all zeros, then you would take your quotient and set it equal to 0. And then you can factor or use the quadratic formula. Okay. I guess we can use the quadratic formula. So B here is 2. A is 7 and C is negative 2. So we get negative 2 plus or minus 4. Negative 4 times 7 is negative 28 times negative 2 is positive 56. (56) plus 4 is 60. And then can we simplify the 60? 4 will divide it, right? 4 times 15. Okay. 4 times 15. So the square root of 4 comes out as a 2. I guess we can still simplify here. Negative 2 divided by 14 is negative 1/7. And 2 divided by 14 is negative 1/7. This is a negative. So your zeros are going to be x equals negative 2. Why is x equals negative 2 a 0? Because it gave us a 0 here. And then the other one is going to be x equals negative 1 plus square root of 15 divided by 7. And the other one is negative 1 minus square root of 15 divided by 7. Okay. So for this question, your answer was only this right here. I just went ahead and did the extra of it, asked you to find the zeros. Okay, so I just wanted to be clear on that. Since it says synthetic, just use synthetic division, then the quotient is your answer. But if it says find all the zeros, then you want to do this part. So for 6, it says consider the following: x cubed plus x squared minus 9x minus 9. And then it says list all the possible rational zeros, determine all the zeros, and then sketch the graph. The possible zeros, you find them by looking at constant and then the leading coefficient. So possible zeros. So we look at the constant, which is negative 9, and we list all the factors of that number. Okay, so 1 times 9 is 9, 3 times 3 is 9, so these are my factors of the numerator. And we're going to divide them by the factors of the leading coefficient. In this case, your leading coefficient is 1. So those factors are just 1. So if you divide all this by 1, you just get the same stuff back. So in your computer, you would enter these numbers here. There's no symbol for plus or minus on your computer. Okay, like they don't have that. So you need to enter 1, negative 1, 3, negative 3, 9, negative 9. Okay, because they don't have the symbol. So then to find all your zeros, then we pick one of these and do synthetic division. Okay. So you can factor this out. It actually does factor, and that might be easier for you. Okay. Or you can use synthetic division. So you would try 1, see if 1 works, and then see if negative 1 works. You would have tried 1 maybe, because that's usually what I start with, is 1. And when you try it, then you see that it doesn't work. It doesn't give you a 0 here, so that didn't work. Okay? So then I would have tried negative 1. Negative 1 is 0, 0, positive 9, and I get a 0. Okay, so since it has a 0, that tells me x equals negative 1 is a 0. Your quotient here, since I started with x cubed, then this will be an x squared minus 9. So we set it, our quotient equal to 0. X squared is equal to 9. Take the square root, so x equals plus or minus 3. So for letter B, your zeros are x equals negative 1, x equals 3, and x equals negative 3. And they all appear just one time, right? So that means that at that point the graph is going to cross. Okay. So the graph crosses. And then just so you can see what you see on your paper, they give you the 4 graphs and then you have to decide which one it is. Well, if you look at the first one, they tell you that you have a 0 at -4. Did we get a 0 at -4? No, so that's not going to be an answer. Here, they tell me I have a 0 at -1. And I have a 0 at +4. So is +4 a 0? No. So you can eliminate some of these, right? -1, yes. -3, yes. +3, yes. So that could be an answer. We still have to check everything else, right? And then this, okay, yeah, 3. Did we have a 3? Yes. Did we have a -3? Yes. But which one's missing? -1. That's not an answer. So your only answer left is this one, right? But that's how you can check. I personally would have graphed it to see what is going on, right? So to graph it, you need the end behavior. So the end behavior, this is a positive degree, and it's it's an odd degree and a positive leading coefficient. So your behavior looks something like this graph. So it's going to rise right and fall left. So if you know the behavior, then you could also see if your graph is doing that. Is it rising right and falling left? Yes. Okay. So that's something else to consider there. Okay. So then you would graph it, plot additional points, the rational zeros. So you want to find all the zeros. This is hard to factor the way it is. So you want to use synthetic division. Okay. In order to use synthetic division, you want to find the possible zeros first. So P is the factors of your constant. Your constant is 30. So my factors are plus or minus 1, plus or minus 30, because 1 times 30 is 30. Plus or minus 2, plus or minus 15, because 2 times 15 is 30. Plus or minus 3, and plus or minus 10, and 5 and 6. For my leading coefficient, that's a 1. So your possible zeros are 1, 2, 3, 5, 6, 10, 15, and 30. So we're going to check one of these, and hopefully the first one we check works. Okay. So the question is not saying find the possible zeros, it wants to know the real zeros, right? If it said find the possible zeros, then that would be your answer here. Okay. So then we would use synthetic division, and you can start with 1, for example, and see if 1 works. So my coefficients here is going to be 1 for x cubed. We don't have an x squared, so that's a 0. And then negative 31 for x, and 30 for the last number. Bring down the 1. 1 times 1 is 1, plus 0 is 1. 1 times 1 is 1, minus 31 is 30. So we get a 0, so that's going to be a good thing. Okay. So we don't have to check all the numbers now. We just found the right one. So your next step is to get the quotient from here. Since you started with x cubed, then we start with x squared. So x squared plus x minus 30. This is your quotient. So what do we do with the quotient? We have to set it equal to 0. And then you can factor or use the quadratic formula. Since I have 30, I always think of 5 and 6. And if I add and subtract 5 or 6, I'm going to end up with a 1. Okay, so let's check if it factors. So 30 is 5 and 6. The 30 is negative, so that means one of these guys has to be negative. But the x is positive, so the bigger number has to be positive, and the smaller number would be negative. Again, if you're not comfortable with factoring, that's okay. You can use the quadratic formula and still get the same answers. Set them equal to 0. So this is my two zeros here. So all your zeros together are x equals 5, x equals negative 6, and the last one is x equals 1. We should have 3 zeros because the degree is 3. So in your computer, the computer already has an x, and it has it like this, x equals. So the way you enter the answer is just going to be negative 6, comma, 1, comma, 5. Okay. So you want to write in standard form. Okay. So to do this, you want to multiply this fraction here by the conjugate. Okay. So the conjugate of the denominator. So 1 minus 3i, the conjugate is 1 plus 3i. And I can do this because I'm really multiplying by 1, right? This whole thing is just a 1. So this is 8 minus 14i times 1 plus 3i divided by 1 minus 3i times 1 plus 3i. But I'm going to multiply it out. So 8 times 1 is 8. 8 times 3i is 24i. Negative 14i times 1 is negative 14i. Negative 14i times 3i is negative 42i squared. And then down here, 1 times 1 is 1. 1 times 3i is positive 3i. Minus the 3i. Negative 3i times 3i is negative 9i squared. Gather like terms. This i squared here is the same as a negative 1. Okay, so we're going to end up with 8. 24i minus 14i is positive 10i minus 42 times a negative 1. And then I have 1. The 3i minus 3i is 0 minus 9 times negative 1. So we get 8 plus 10i plus 42 divided by 1 plus 9. 1 plus 9 is 10. 8 plus 42 is 50. However, it needs to be in standard form. We need to simplify this, right? What is 50 divided by 10? And 10 divided by 10 is 1. So my answer is 5 plus 5. Okay, number 8. Use the quadratic formula. So here we get x equals negative b. A is 1, C is 2. Negative negative is positive. Negative 2 squared is 4 minus 8. 4 minus 8, negative 8 is 4 minus 8 is negative 4. Let me write it up here so we have more space. The square root of negative 4 is going to be what? The negative comes out as an I, right? And the square root of 4 is what? 2. I can divide by 2 here. 2 divided by 2 is 1, and 2 divided by 2 is 1. So my answer is x equals 1 plus or minus I. The way you need to input it in your computer, since you don't have this symbol, you would enter 1 minus I, and then comma 1 plus I.